Hello everyone, welcome back to the last section of this course, Voter Model using Gossip Logarithm. This is the first video in which I'm going to introduce you on what is Voter Model Logarithm and how we can use it in Gossip Logarithms. So Voter Model is a mathematical model of opinion formation where a conclusion has to be made on a single opinion based on the majority wise. It falls under node-based asymmetric gossip logarithm, where two nodes are triggered at a point and they pair with each other to exchange the information. So voters are located at each node of the network, each voter having an opinion. Let's say for the sake of argument, we have three possible opinions: red, yellow, and green. Any one of the voter from the network can take an opinion of one of its neighbor node with some probability q. Let's say node A at time t has opinion red, and it wants to take an opinion from its neighbor node B, whose current value at that time could be any of the value from red, yellow, or green. So the new value of this node A at time t plus 1 would be its own value with probability 0.33, and the new value yellow and green with higher probability of 0.66. Value of q can be obtained by dividing 1 over all possible opinions that we have. So the theorem of voter model can be stated as: given in a connected graph, a voter model converges to consensus where all the healthy nodes decide on a sane opinion, which is the agreement property of the consensus, and the decided value is the input of at least one of the healthy node. So let's say if 10 nodes started off with value green and yellow, then there is no possibility of converging into the state red. The concluded opinion would eventually be either yellow or green. And eventually the healthy nodes have to decide on an opinion, which is fulfilled at the start because nodes already have some opinion. So the final value of all the nodes in a given network at a finite time could either be one of the possible states of the opinions. Either it could be red, yellow, or green, with higher probability of 1. Although during the circulation, the system will fluctuate, but it always reaches an absorbing state called mass convergence. You will understand more in depth what I'm saying here when we will dive into the practical project. So bear with me and absorb some theoretical knowledge of the voter model before we dive into the practical model. The probability of converging to a given state is proportional to the initial state of the nodes. For example, if we have 5 nodes in a network and the initial starting state is that 3 nodes initial value is red, 1 initial value is green, and 1 other node's initial value is yellow. So it is more likely that the final opinion will be mostly of the majorities. In this case, red has the highest probability of 0.6, followed by green and yellow with 0.2. So to give you a quick recap on gossip logarithm is where the nodes communicate over a network by sharing the knowledge with one of its neighbor node. And talking about the node-based asynchronous logarithm, which the voter model is based on, is where a node n triggers uniformly at random, and it selects a random neighbor u, and then it exchanges the value from its neighbor at the next time slot. We will start off by implementing this gossip logarithm in a complete network. For that, we need to link all the nodes with each other so that there is a direct path between each node. Now, in order to start gossip logarithm, we are not going to send an input from any of the node from a USB through laptop, but instead nodes have to trigger, which means that sending a pair request uniformly at random. And we also need to make sure that every node must get equal chance of getting triggered. It shouldn't be like A and B are triggering most often and B, E, F, C are not triggering much. So we need a fixed probability rate of nodes getting triggered equally in a network.